agenda was the other way around, so I was not coming here in front. Very happy to be here with this group. We're going to talk about telco network going cloud native and cloud native transformation momentum in Deutsche Telekom Technik, which is NT network technology subsidiary of Deutsche Telekom in Germany. My name is Vuk. I'm a cloud native platform lead in Deutsche Telekom Technik, and today with me is Michal Sewera, who is online, hopefully via video link, and he is cloud native 5G core and campus network lead in Deutsche Telekom Technik as well. I'm just giving a second to sort out the technical issues. I guess.
No.
Yes.
Reverse? Yes. Online. You have one. I mean, here, online. Should be okay now. Right?
Yeah, hello.
Yes.
Can you hear me?
Yes, it should be okay.
Super. So I hope people in video conference can hear us, and then Michal as well, because he's going to join later in the presentation. So, in order to position what actually are our different roles and where do we contribute in an ecosystem, I prepare a simple diagram which shows our cloud native landscape and in DT how we like to see it. Based on it, you will probably notice that I'm coming from the infrastructure angle of view, because my role and role of my team is to deliver a platform, unified platform, or how we like to call it and how it's called today, horizontal cloud, that hosts many of the cloud native network functions. And this is why the 95% of this picture is infrastructure view. I don't want to drive and explain the entire picture, but I want to point out that we differentiate the infra-cloud layer, which is the machinery below, the CAS layer, which is this in the middle. It's a bit of distorted here because of the fonts, and the PaaS layer, platform as a service layer. On top, we have a CNF. We have many CNFs, and I'm sure Michal would be able to make such a simple diagram also for his CNF. I tried to take a photo of 5G core, decreased a few days ago in a production, decreased the font in the terminal to the minimum, and increased the monitor resolution as much as possible. I still couldn't capture it fully. There are still a couple of centimeters below. But what struck me is similarity to something we all know from the movies. And I guess Michal will be able to relate to that, because it feels really like that when you get into really hands-on approach. So, having said that, I want to move forward. CAS, explicitly put here, it's not container as a service, as many think for it. For us, it's a cluster as a service, and essentially we call it TCAS. TCAS is, in a nutshell, a open source based Kubernetes CAS management engine that has a main function and main role to enable possibility to create and easily manage many clusters in many locations. This is symbolically represented here. The clusters, the Kubernetes clusters for the network functions that we serve are usually allocated per system or per vendor. They are not per really definition of the network function, because one 5G core, for example, is taking one cluster, but 5G core has a number of network functions in it. So this is a segmentation. We of course have a virtual machine-based clusters, but at the scale of Deutsche Telekom Technik and network domain, this is rather a side gig, side thing, which we usually use for a management application. The focus of TCAS which is our horizontal cloud platform, I want to reiterate that, is to address the core network workloads and the service platform workloads. Out of scope, explicitly, because we want to do one thing at a time and do it good, the out of scope is ORAN and edge workloads. We started actually 4 years ago with small steps and reached the full momentum, and we are now in the full swing of cloud native transformation. So I will not be able to share the percentages, but it's a really a major ongoing transformation that we are undertaking. Back in 2020, we started small with a main motto, ship fast and iterate. And at that point in time, we shipped our first release and first product, which is TCAS on top of the VMware platforms, of the existing VMware platforms. We didn't build anything new, we just used what is there, hooked on top on it via APIs, and provided first clusters for some POCs and for some smaller network management applications. Then we jumped on the next goal to provide bare metal Kubernetes, targeting the more serious network function CNF workloads like 5G, telephony application server, intelligent network, and so on. And we delivered that in 2021. This is a platform on which some of these workloads went into production last year and are going to go into production in a few months. In this case, we decided to take everything in one team, from the underlying infrastructure, compute, network storage, in order to be able to iterate fast, to make architectural decisions fast, and create by that a blueprint how the bare metal Kubernetes as a horizontal cloud should look like. And then after we delivered that, we moved into the next phase, which is our current focus. This is what we call TCAS on Baymax. I'll explain later what does it mean, but essentially we decoupled, disaggregated again, and we are scaling the underlying infrastructure separately from the CAS layer. To date, we are having more than 40 applications in the onboarding or in the let's say running on the platform in different stages, be it production or be it still in some phase of onboarding. These applications vary like from typical network functions up to some management or support system, like you will see here, DNS, the main authoritative DNS of the entire ecosystem, or MRF functions, NDL, network data layer, and so on and so forth. And this is when we say a horizontal cloud, and I guess it's a common definition of everybody in the room. We assume this is one cloud for all these network functions, CNS, and other applications. Talking about, because the question was status of the transformation progress and challenges. So first, talking about status, we are running as of today in 8 locations on a different, let's say, variations of the stack, having 5,800 servers deployed for a bare metal variant, 175 plus clusters. It's increasing every day. So I had a presentation from January, it was a minus 20 clusters, producing them and delivering for the onboarding of the network functions. Utilization is growing, so we have front-loaded capacity, so we are having like 1,800 nodes utilized, and you'll see that the focus is on bare metal because we have also virtual machine clusters, but they are below 1,000 virtual machines. For future, which is for us end of next year, we are targeting to have around about 7,500 compute instances, servers installed, more than 500 clusters, utilization around about 7,000 nodes, and also scaling on the virtual machine front. And all of that in 14 locations. So this is when we talk about public cloud. There are different options and use how to see it, but public cloud doesn't have this footprint, and each of these locations has, in average, 500 servers, multiple racks, and network, and so on. So it's not the scale that current public cloud is enabling. We have solved a number of challenges on the way to this current status that we have over the last 4 years. One of the challenges was multi-cluster fleet management at scale. So I don't want to confuse that with this multi-cluster management for the workloads, where Luis was explaining the vision of having the dynamic allocation of the site and so on. No, here we are talking about possibility to create and manage the clusters as a generic, as a kettle, and to give them as a platform to the network functions related teams. So how did we address this challenge? I'll explain on the scenario of cluster creation. We have mentioned a couple of times Flux and Cluster API. This is where we start from, having operator, management cluster, Cluster API, and Flux. And we have a tooling. First of all, we have a common contract and manifest, how to describe the cluster for a particular network function, including the network needs and so on. We run that via tooling, which is at the moment CLI tooling. And that gets the result of this rendering gets pushed into Git, and out of Git it gets picked up by Flux. What does management cluster do for everybody from the who is closer to the cluster API? It will talk to the compute pool, bring up the cluster, the empty cluster. We would push the CNI to get the networking in the cluster. We will get Flux in it, and that cluster will wake up and say, hey, I'm this cluster, but I don't know what role I have. It will be pointed to the Git, and based on Git, it will fetch its cluster configuration, including network configuration, including network integration, and will be ready for use, installing all the components and so on and so forth. So that's actually the example of cluster creation. We have for a cluster lifecycle updates and so on, but I want to point out here major features like rich networking, off-the-shelf security policies, off-the-shelf airbag. We are enabling third-party components to be by separate teams loaded on the platform and managed independently. And it's a monitoring that comes off the shelf, and then GitOps for the application or CNF deployment that comes off the shelf. Mikhail is going to talk about that a bit more. Next challenge that we had was how actually to scale that approach, how to scale the need and the demand to have a hardware at the place where you need it, in the form and in the shape that you need it in order to do that. The answer for that is, in our case, Baymax, which is abbreviation for bare metal as a service for anything. So essentially, it's an entire work for itself and would also be a subject of a full day deep dive. But in essence, what it does, based on the intent, that we need certain amount of hardware at some location, it would, through the automation, generate the orders, inventorize this in the systems, and then when the hardware is shipped on the site, we'll boot it up, we'll do the cable checks in an automated way, and it will provide the possibility to order compute and networking and storage via an API. And this is actually the API that TCAS as a platform uses in order to get the resources. Third challenge that we have experienced over the years was actually integrating CNF into network. It was mentioned today as well. It's not easy, especially in environments like ours that grew organically over the 20 years since IP transformation began. We have a very segmented network. We have a lot of VRFs, a lot of domains and so on, which are having duplications and so on. And this is a sort of jungle that cannot be easily addressed in a traditional ways. What we actually did is we came up with a notion of host-based routing. We moved the leaf switches from the traditional spine leaf architecture, or we actually added another layer of leaves that are residing on the hosts of Kubernetes clusters and having the router on the host. And this enabled us to offer to the workloads, to the application standard layer 2 connectivity. The applications, they think, hey, we are having just a traditional normal network, but the layer 2 ends there because it's up to the cluster node layer 3. The traffic gets packaged into EVP and VXLAN and by means of BGP transported in the fabric. What that brings to us is possibility to realize network connectivity without touching the network, and even complex network connectivity, possibility to enable self-service for network integration in a GitOps way. We can use one pool of servers that are generically configured like a kettle to serve all the clusters. We are having ECMP, equal cost multipathing for a superior high availability, and more interesting, or probably equally interesting as other things, is we are able to monitor network connectivity for CNFs via standard cloud native tools like Prometheus and tools from the ecosystem. This concept enables us to offer some things that are not possible without host-based routing, like egress not without having a firewall in the network, like also possibility to configure safely the complex route leaking scenarios, HA for ingress, and a possibility to have a direct routed pods. In terms of challenges, the white paper and manifesto and white paper about cloud native transformation challenges for the telco and how to accelerate them. I will not repeat that, but I really recommend to everybody, this is a fresh paper, a bit more advertisement for it. Just read it because there we, with other operators, Orange, Telefonica, Vodafone, Telus, and others, we summarize really what we see as a challenge and what should be addressed. I will focus here on a couple of challenges that we have in practice as of today after solving some of the challenges that I mentioned. The next challenge that we have is a change management in the cloud, or how to make, how to serve ITIL processes, which are still and are there as a request, how to serve them for the frequent and smaller changes that we, as of today, we have 250 changes through the GitOps process and scale that we are today, and this is going only to increase. So that's one challenge. Another challenge is how do we accelerate the validation of the workloads, or how do we get the CNFs to get validated faster at the speed of upstream. Example, today we have a Kubernetes 1.28 and probably any of the network functions or none of the network functions is validated to these Kubernetes versions. Not to talk about some more specific validations. And the last point I have to emphasize is when we look at the network functions that we get off the shelf, their readiness for enterprise deployment is light years behind what where they should be, because they have a hard time with a stronger security posture of the infrastructure. They have a hard time with the standard policies, and technically it's easy to relatively easy to adapt them, but we see vendors are not there yet to be able to make these adaptations on a short time frame. So these are the things we are going to deal on the platform side, on the infrastructure side. Now I hope that our voice connectivity is good here, and I'm going to hand over to Michal to talk about how did we completely change traditional telco model for 5G core. Michal, can you hear us? We cannot hear you yet.
Cannot hear me?
Yeah, yes, we can hear you now.
Okay, so is my voice out? I am audible right now?
I think yes. Everybody is nodding in the room, so you're with us.
Okay, cool. Super. Perfect. So let's get started. And of course, if you will have any questions, please let me know. So first of all, as Vuk said, we are in the journey. This journey started actually more than 3 years back. And 3 years back, we decided that 5G use case, 5GSA use case is a perfect story for transformation towards a new cloud native model. I'm always saying that it's actually not only 5GSA, because what we are building is a converged form where we are offering full-fledged services containing 4G landscape as well. But the important part of this exercise was that this is completely new operational model, not only in the context of running things on containers in Kubernetes, but also in terms of entire responsibility landscape. And I think it was mentioned in a lot of presentations before. Basically, the key challenge here is that we are decomposing system into a lot of components, and now no longer there is a single responsibility for a vendor, which basically means we need to build in-house competences, not only for making all this connected together, but it's also very important to have the competences to perform entire lifecycle management. And I think that is, to be honest, one of the biggest challenge which we still have. I will have a dedicated slide to mention about it. So if you think about virtualized silo versus web scale, the key difference is that now we are focusing only on certain microservices which we expect to be delivered by the vendor, and a lot of other components, things like service mesh, CNIs, logging, alarming, that should be all open source, and we call it melting the cheese on a pizza. So it's basically the objective is to provide unified framework for all other applications as well. So when you switch from one vendor to the other, you should not make any difference in terms of how the lifecycle management looks like in terms of configuration management, scaling, deploying, and so on and so on. But the key story out of it is that there is no longer a single point of responsibility, and that's a very clear message. So I think that running things on containers does not mean that it's cloud native. Responsibility matrix is completely different story, and I'm always saying this is not yet another black box. So Vuk, if we can move to the next slide. Okay, perfect. So what actually we did, we tried to eliminate any vendor-specific configuration framework. And of course, it was a journey. We started with the point where that was still part of the ecosystem. Finally, after 3 years, we have a solution where all components, not only open source elements like Istio, but also network functions coming from the vendor, they are managed exactly in the same way. So basically, we reflect desired state of the cluster in our platform, which is Magenta CI/CD. So we have entire configuration sitting in Git. Whenever we want to perform any change, not only in the context of configuration management, but also in terms of upgrades, the flow and entire lifecycle management looks identical. And what is also reflected on this slide is that the role of engineering team and that is something which we built also from scratch, mixing competences from different worlds. It's no longer just reading the documentation from the vendor and deploying what is said by the vendor, but it's more as an integrator role as well. So in essence, we write a lot of pipelines which are part of the lifecycle management. So for example, in ideal scenario, if you do a change of the configuration or a change in the ecosystem, the pipeline itself should be able to validate if this change is not harming the system. So you can think about even extended scenario where before deploying it in production, you are testing it in an integration lab, then finally in reference lab. And as part of this testing, you also expect to have some probes which can check if the flow of the service end-to-end is really fine. What is essential part of the slide is that you don't see any northbound interface coming from the cluster, which typically is always present in those kind of deployments. So Flux here is not only used to deploy the things, but it's basically used for entire lifecycle management of the application. So as you can see, there is no northbound interface with any netconf YANG or any vendor-specific configuration framework, which is typically used by in traditional deployments, even if they are running in containerized environment. Good, perfect. Vuk, if we can make the next slide, because now I would like to focus on more challenges, which I would like to highlight. So first of all, as Vuk mentioned, we are taking a lot of small changes in the system from different levels. If you have such a disaggregated ecosystem, the change might come from Kubernetes, like a, release change, but the change might come also from security requirements because there is a vulnerability and you need to implement or you need to upgrade a certain component. So that is leading into a point of high frequency of changes. And of course, if you think about the quality and complexity, that is really making a completely new challenge. So before in the traditional systems, you typically had one major software upgrade per year. You spend a lot of time in freezing environment and testing it in a lab. Now we are talking about the system which needs to handle a lot of small changes, also within the life cycle of the system in production. So the key question is how you will de-risk it from the service perspective. And unfortunately, I believe it will still take some time in the industry, for the telco industry, to solve it and to beat the numbers which were created in terms of the quality in the legacy systems. Our solution for it is service assurance based on non-stop testing principle. So what is our objective is actually to treat any deployment in a production as a system which is non-stop under the test as well. We are investing in agents which are testing the service end-to-end, not only from real devices perspective, but also from emulators or generators like Spirent. And the essential part of this is also root cause automation. So we have a number of projects. We have a bigger initiative, which we call BitStop. And as part of this initiative, we are trying to implement automated way of sorting out what's really the problem, what's the root cause of potential problem. And I think that for us, for the entire industry, to be successful with this transformation is not only to prove that we can deploy it, because this part is already done for us. As Vuk mentioned, we are part of this since 2020. And in terms of 5G service, we are live since 1 year for B2B market. For us, of course, it's absolutely essential to improve end-to-end quality. So ideal scenario is to survive things like rolling upgrades or ISSU system upgrades without ability for any manual troubleshooting or any root cause analysis which requires human intervention. Right, and I think that would be pretty much it. I'm just looking at the time, and yeah, that's basically it. So Vuk, go ahead. I think we have a slide with conclusions, so
yes.
Maybe let's start with you.
So I'll take over here briefly. So you've seen based on our titles, Cloud Native Platform Lead, Cloud Native 5G Core Lead. We are already cloud native, but not based on the titles, based on what we do in the everyday business. We learned a thing or two over the last 3 years about cloud native in telco, and we are running these things, as Michal mentioned. 5G is live for advanced B2B use cases. It's of course small scale, it's not mass market. This is coming soon, but it's still a proof of these efforts and how it can be done. Now, talking about our future, what we are looking towards the next months and years. On the platform side, we are continuing to scale and to deliver more capacity and more features in an ever greener way. We are also looking at what this kind of infrastructure gives us as a possibility to dynamically manage the capacity and workloads and so on. So there will be a lot of possibilities to enable higher efficiency and lower the energy consumption. The other thing that we need to do is to standardize the life cycle and also maintenance of the platform. It's now as a platform there, but there are some parts that we are looking to productize in order to simplify and increase efficiency in life cycle management. We need to automate a change management process around the ITIL because it's not possible to run it in a traditional way without automation. Maybe this is a subject of AI Ops as a next one of the next stages, and one of the things which is very important. We know we are a bit on our own here. We use what we built in DT, but we would like to contribute back and to contribute more to the initiatives, community initiatives like Silva and LFN working groups and so on and so forth. So that would be on the platform side. Michal, if you want to jump in on the 5G application side.
So continuing with the application part. So as I said, first of all, running applications in container does not mean that the application is cloud native. And I think that one of the first paradigm is to check with 2 factors principle and cloud native manifesto in terms of real vendor readiness. We see, unfortunately, that there is a different speed for different vendors. Some of them, they want to keep a more traditional model. So even if they are bringing containerized application, they are still managed in an absolutely silo way, and that's definitely not the benefit for the organization. A second point would be a transition to GitOps-based lifecycle management as a foundation for the new telco processes. So when I say GitOps principles, it basically means more engagement on an engineering side for things like writing the pipelines for validation and running entire lifecycle management with GitOps principles. Also switch towards the declarative deployments compared to the traditional way with imperative. That's absolutely essential part if you want to really make a difference compared to traditional deployments. And last but not least, absolutely proactive service assurance even in operational environments. I think that for us, for a telco industry, once we will do this transformation, the next years would be for sure with a challenge to master the operations. You see, with years of traditional silo-based deployments where vendors control everything, it was sooner or later quite obvious that we can beat those 6 nines. We had examples of traditional deployments which they have less than 1 minute of outage per entire 1 year. Well, 1 minute outage you could easily eat for the breakfast with unsuccessful rolling upgrade. And that is something, so you can imagine that if you do those rolling upgrades like many times per year, how much higher probability of potential failure you have. And that is something which definitely we need to also explain to our management and to our community that achieving the same KPIs and the same quality for the cloud native deployments, if they are really truly cloud native, not yet another silo consolidated in the box. That will for sure take some time, and I believe that I would expect also from the events like KubeCon, like Telco Days, a broader discussion about things like how we can really provide a solid quality out of this. That would be my takeaway. And of course, any questions, we are more than happy to answer.
One question. Sorry, we are running on time.
Thank you for the presentation. Very interesting. This is John from Docomo. I have one question. So you mentioned that you are able to treat all the network functions, any vendor, in the same way in terms of configuration. How do you model the network functions? I mean, do you still rely on the vendors to actually provide the model of the network function so that it can be ingested into your platform? Or did you told the vendors, please conform to this at least specific list of information that I need to know about the function so that I can make a deployment for them? How did you manage that?
We have two parts of the answer. I guess as I would expect that question to come, I put one backup slide.
It was not prepared.
And it was not prepared. I put the one slide which is showing the platform view. When we want to create the infrastructure and instantiate the cluster for a network function, we need a manifest and custom resource which includes a lot of network information. The network information here is also obtained by API on the fly based on express intent. And then what we do, we create a cluster so that network function can come on top. So this is one part of modeling, but maybe I'll let Michal to answer potentially from the network function view how he sees this topic.
Absolutely. I think that so answering this question, I think that the biggest challenge for us would be to eliminate network element managers. Because actually, if you will eliminate network manager and do this sort of exercise, like, okay, what does it mean that I want to perform the lifecycle management of the application? Then exactly what Vuk is showing is a natural next step. So a lot of vendors are doing the following step. They use tools like Flux just to automate the deployment. But then once the deployment is finished, they are disconnecting it. They are using their own network element managers to control the solution. And for us, a key story was exactly to change it. So basically to assume that things like Flux with reconciliation is not only used for deployment, but also for lifecycle management. And that is, to be honest, the most important requirement. Everything else comes as a natural consequence of this principle. And of course, in terms of modeling, yes, that's absolutely a valid point. You need to also distinguish user plane versus control plane applications. So alignments on things like SNIOV profiles, worker node profiles, etc. That's absolutely must have. But I would say that this is more easy. More challenging part is exactly the conformance to this GitOps model, where you can do entire lifecycle management following the same principles.
Thanks, Michael. Just a follow-up question, quick one. Do you think that there are opportunities around potential standardization on this GitOps model, or do you think that there is no need for it? What are your thoughts?
Absolutely. I love what you just said, and I would be heavily pushing for this towards the industry. If we as a community can do anything, and I believe that this CNCF certification is part of it, that we could somehow push the vendors that they will not only use this buzzword like cloud native in their presentations, but they will also conform with the deployment towards this, that would be really great. I have tons of examples, like for example, vendors not respecting Kubernetes network policies because in their own black boxes, they don't need it. But of course, once you will go for an extra, for external cloud, like you're deploying things on that shift, all things like network policies and so on, they need to be absolutely respected. So I believe that any sort of certification of this one would be absolutely a big benefit for the industry.
Thanks a lot, Michael. Thanks a lot.
You. I didn't warn
Many thanks.
Michal. I didn't warn you that we have quite some vendors in the room, but that message was taken sincerely and authentically from you. Thanks a lot.
Thank you so much.
Thank you both. And,
Thanks.